So today what we're going to be talking about is the commutative property of multiplication. We're going to be talking about the associative, property of multiplication, and finally the I already said that. The distributive property. Now, the commutative property of multiplication is basically that if you have numbers, for example, 6 times 4, we know that equals 24. If you multiply them in a different order, 4 times 6, you still get 24. So for a definition for this, let's say the order of multiplication doesn't matter. Now, to show you why does this work, why can you multiply things in any order and have it be the same? So the first one, let's do 6 groups of 4. So let's do 6 groups. 1, 2, 3, 4, 5, 6 groups of 4. So this is 6 groups of 4. 6 times 4 equals 24. Okay, so there's 6 groups, and there's 1, 2, 3, 4 in each group. And if you counted every single square in this box, there would be 24 of these small squares. Now, what if we do it the other way? So let's do 4 groups of 6. So there's 4 groups. 1, 2, 3, 4 groups of 6. So there's our 4 groups of 6. 4 groups of 6, or 4 times 6 still equals 24. Now, even though the groups are written differently, they're still the same number in 6 times 4 and 4 times 6. So let's see. You could write, so if I wanted to show you where, on this top one, you see 4 groups of 6, but if I wanted to show you where my you see 6 groups of 4, if I wanted to show you where my 4 groups of 6 are, all you would have to do is draw these lines the other direction, which I don't know how well you can see that. Yeah, so the yellow lines are the 4 groups of 6. So no matter which way you multiply something, you're going to get the same number. 2 times 8 equals 16. 8 times 2, what does it equal? Still equals 16. All right. The next thing is the associative property of multiplication. Now, the associative property of multiplication, if I gave you the problem, let's see, if I gave you the problem 2 times 3 times 4, we can multiply any two of these and then apply that answer by the third one. And this kind of goes along with up. It kind of goes along with the idea of up top, where the order you multiply doesn't matter. So 2 times 3 is 6, and then we multiply that product by 4 to get 24. Okay? So another way we could do it, 2 times 3 times 4. If we multiplied 3 by 4, we would get 12. And then we'd have to take that product and multiply it by our last number. 2 times 12 equals 24. So if you have a series of numbers that you're multiplying, you can multiply them, you can group them in any way you want. If you had 5 times 10 times 2, 5 times 10 is 50. And then we multiply it by the last number 2. 50 times 2 is 100. We could also do 5 times 10 times 2. We could do 10 times 2. What's 10 times 2? It's 20. And then we multiply it by this number we haven't used yet, which is 5. 5 times 20 is 100. So again, if you have a series of numbers, you can multiply, you can take the product of two of them and then multiply that product by the next number you need to multiply by. Okay, so, and that all kind of goes in the umbrella of the order that you multiply in doesn't matter, right? You could multiply 5 and 10 first, you could multiply 10 and 2 first. As long as you end up multiplying all three numbers, your answer will come out the same. Finally, the last one I want to look at is the distributive property. So let's do 8 times 7. What is 8 times 7? 8 times 7 equals 56. But let's say that you wanted to break this problem into something easier. Maybe you haven't memorized what 8 times 7 is yet. Well, let's break it down into either multiplying by 2 or multiplying by 5. Okay? Because I think that those two are pretty easy to do. So let's look at 7 and see that 7 is the same as 5 plus 2. Okay? And we want to multiply 8 by that so that it still equals 56. Now, what the distributive property means is that if we take this 8 and we multiply it by the 5 and we multiply it by the 2, we'll still get 56. So what that would look like is 8 times 5 plus 8 times 2 should still equal 56. All right, what's 8 times 5? 8 times 5 is 40, plus 8 times 2 is 16 equals 56. Is this true? Is 40 plus 16 56? Yes, because 40 plus 10 is 50, plus 6 is 56, so that checks out. Another way you could write it, the same problem, let's say we wanted to break 8, instead of doing, okay, 8 times 7 equals 56. Let's turn this 8 instead into 5 plus 3. Okay? 5 plus 3 times 7 equals 50. So now we do the same thing we did over here. We take this 7, we multiply it by the 3. We take the 7, we multiply it by the 5. And when we do that, what we get is 5 times 7 plus 7 times 3. 5 times 7 is 35. 7 times 3 is 21. Does that still equal 56? It does. 35 plus 20, 35, 45, 55 plus also works. Now, why does this work? Why does this work? Well, let me show you. So, for this one, 8 times 7 equals 56. Let's draw a box. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know that this represents a multiplication problem. The top is 8, this side is 7. Okay? But let's just say we took this side 7 and we broke it into 5 plus 2. So 1, 2, 3, 4, 5. So this part is 2 and this part is 5. So now, without changing the size of the box, we've broken up 8 times 7 into one box that represents 8 times 2, which equals 16, and one box that represents 8 times 5, which equals 40. So, even though we've broken up the 7, we still have the same amount even though we've broken up the 7. Okay, so let's do that again over here with the way we did it when we broke the 8 up. So let's do 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then 7 coming down. Okay, so we have 7 on this side, and this whole side is 8, right? Just write 8. Okay, but what can we break 8 into? We can break 8 into 3 and 3 plus 5, right? 3 plus 5 equals 8. Now, instead of having, well, we know that this box is 7 times 8, but now we've broken it into 7 times 3 plus 7 times 5. We know that 7 times 5 equals 35. We know that 7 times 3 equals 21. So when we add those together, we still have 56. We have not changed the size of the problem. We've just cut it in half. Well, not directly in half, but we've cut it into pieces that are easier to manage. So that to recap, the commutative property says it doesn't matter what order you multiply things, 8 times 2, 2 times 8, either way you still get 16. The associative property of multiplication says that if you have a string of numbers that you're multiplying and you take the product of the first two and multiply that product by the third number, you still get the same answer. And it doesn't have to be the first two. You could do it with the last two as well. So 2 times 3 is 6, times 4 is 24, 3 times 4 is 12, times that 2 that we brought down is still 24. 2 times 3 times 4, no matter what order you multiply it in, is still going to be 24. And the very last one, distributive property of multiplication, says that if you break numbers down into, if you have a multiplication problem and you take a number and you break it down into two numbers that add up to it, like 5 and 2, you can take the number that you're multiplying it by and multiply it by both of those numbers that you are adding, and you get the same number. So distributive, you took this 8 and you distributed it to the 5 and the 2, which is the same thing as just multiplying it by 7.